parents and students. This is Miss Fernandez. So I know last week we've been talking about just reviewing double digits times single digit numbers. Well, this week and sort of started last week, we just started double digits times double digits. So what I'm going to do today is I'm going to show you some strategies to hopefully help you either as the student or as parents in how to navigate the homework this week. First things first, here are some strategies that we are probably going to be seeing on the homework, specifically the online homework, because the online homework is always very picky. The first one you're going to notice is we have arrays versus area model. Okay, now here's the difference between arrays and area models. There's only one big difference. An array has a grid, an area model does not. That is literally the only difference. And I'm going to show you kind of what they look like. Now, I do want to let you know, specifically parents, we don't really use arrays a lot. But I know on the homework, at least in 4-2, it does use, you do have to answer questions in that ask you to find the array model that matches the multiplication problem. My bad. I don't know why that left my brain. It's the case of the Mondays. I'm so sorry. But anyways, so I just want you guys to be able to recognize what they look like and not to be afraid of them when you see an array. I do want to warn you though, on some of the problems when you are doing arrays, I don't know why they decided to give you really huge numbers. They're all double digits, but they give you really huge numbers, but tiny, tiny squares. So I promise that the examples today will be really, really easy. So let's start with arrays. So as I said before, arrays are just like the area model. Okay, and I'm just going to do, at least just to show you the array, I'm going to pick really easy numbers. So let's say, here's my box. Let's say that my problem is 10 times 15. Okay, we're just going to keep it simple, easy. Now, I know a lot of you, as I said, I think in the last video that I made, a lot of you want to automatically do the standard method, which is fine. However, the homework is going to tell you absolutely not. You're not doing that. However, on the test, when I give out the test, students will be allowed to use the standard method. However, in the case of just learning different strategies, we do want to encourage them to use, to not be afraid of the different strategies. So for right now, we are going to talk about arrays. Now, first things first, an array will always have a grid. So as you can see, so I'm just going to split this up, okay, by 10 and 5. Oh, whoops, yeah, 10 and 5 for 15. My second number always goes on top, and my first number always goes on the side when we are dealing with an array. Okay, so you're going to notice, especially on some of these problems, that a lot of your arrays are split up into squares. So give me 1 second. I gotta make sure that I'm splitting these up correctly. They're not gonna be even, but I wanna make sure that I have enough rows. So 1, 2, 3, 4, 5, 6, 7, oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's about 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so as you can see, I'm just making grids just to kind of show you what each box is supposed to look like. And you know what? Let me use a different color for this part. Whoops, excuse me. I'm just going to use a different color. Just so you guys can see how we split it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is kind of what your array looks like. Now, mine is not perfect. But this on the homework is kind of what you're going to be looking for. Now, arrays are usually divided into grids. And the grid is usually going to be the width and then the length, just very similar to like finding the area of a rectangle. But the only difference is they split each up based off of how you split up your second number up top. So as you can see, I split up 15 by 10 and 5. So in this first square, this first portion, my width should be 10 and my length should be 10. So just for argument's sake, this is 10 and that's 10. Okay. Now, in this part right here is very similar. The only difference is it's 5 as the length and then it's 10 down. So this way you can see that this is 10 times 10 and 10 times 5. Now, in an array, essentially what they want you to do is they want you to count all the squares. I find that a bit tedious, all right? And I know a lot of you probably are like, well, I agree with you on that. The good thing about arrays is they are very similar to to area models. The only difference is area models, they're much cleaner because they don't have all this extra jargon. They don't have the grids. So they are very, 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 very nice. However, as I said before, in the homework, what it is going to ask you to do on some problems is it's going to ask you match the array to the problem before you solve it. They want you to match the problem to an array that they give you, and they're really mean because they don't actually give you the numbers except like this. So the easiest way that I can describe this is, one, make sure that your top number obviously matches one of these two numbers, okay? So now, typically speaking, the best way to know if it's matching is one of these should be matching. I prefer if they did it like this, where it's like 15 is on top and 10 is on the side. However, that's not the case because multiplication, you can flip it and switch it and it would still get you the same answer. So if I was to do 15 times 10, I would still get the same answer. Sorry, that was an ugly way of doing that problem. So you will notice that on some of the homework, it is going to give you like multiple choices. So please, please, please be very careful and pay attention to what it is that it's asking you. Is it asking you for find multiple arrays that match the problem? Or is it asking you for what array matches this problem? So in the case of 10 times 15, we're just going to ignore that. We're going to ignore this. I just wanted to show you that, yes, multiplication, the answers will be the same no matter how you flip it or switch it. So the best way to do this is to, one, make sure that your width all the way across matches. So right here, this should be 10. And then over here, this should be 10. Great. So we can definitely check off that, yes, this down here is 10. Now, this is where it gets tricky because you have to pay attention. Now, on your homework or on your child's homework, the good thing is they color code this. So these will be different colors. Unfortunately, I don't have a lot of markers at home, so I'm just using what I have. So I split them up. So we're just going to focus on the 10 square. So after I count my width to make sure that both of the parts for my split up number have that 10 width, now I have to add across the top to make sure that my top matches. So let's see. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 squares at the top, and then I have 1, 2, 3, 4, 5. We have 5, and we should know that 10 plus 5 gives us 15. So that means we have 10 times 15. So if this was one of the answer choices for 10 times 15, this would be the correct answer. So that's how you find it. Unfortunately, it's tedious. And again, as I said, the array model that they give you, their squares are like super microscopic. Now, they're nice that they give you magnifying glass, so your student should be able to zoom in and get closer. But I personally do not like it this way. However, then it comes to the fun part where it asks you to then solve. And just like in the area model, which I am more than happy to come over here, the area model is the same, all right? The same way for an array. The only difference is with this area model is I'm not gonna put all the grids, all right? So that's what makes the area model so nice, is you don't have to worry about those nasty grids. But I know on some of the homeworks, there are 2 parts. It is going to then ask you to solve it. So I always tell my students, I say, look, as soon as you get the array, just use the area model, because they're the same exact thing. Just one has a grid, one does not. So now I just multiply. 10 times 10 is 100. And then 10 times 5 is 50. So my final answer is 150. All right. So that's arrays versus area model. Now I'm going to continue talking about the area model, but this time I'm going to talk about how some numbers they're not exactly they're not very nice. The last one was really nice because we had a number with a 0, but that's not always going to be the case in some of your homework problems. You're going to get some numbers or some equations that are going to be like this. Just for argument's sake, let's say we have 25 times 30. Not 30, times 36. Okay, so I have 25 times 36. Okay, this is where I really, truly love the area model. And even partial products if you're feeling froggy enough. But the area model in cases like this is probably going to be your easiest one to use. And I'll even show you the partial products on how to split this up. So first we're going to start with the area model. So the area model for this problem, all right, is going to be slightly different. Now the box is still the same, all right? The box is still the same. It doesn't change. The only difference now is that we have a number that doesn't have a 0. And I know you're thinking, oh my gosh, that's not nice. That's so mean. It's actually much easier than you realize. So I'm just going to make my boxes. And as you notice, my boxes are slightly different now because I have not just 1 row, but now I have 2 rows. So in 2 rows. So now it almost looks like kind of a nicer big grid, but it's not a grid. All right. Now what I do is I take my 2 numbers and I'm going to put them in expanded notation along the length and the width of my rectangle. Now, I always tell my students that the first number is always going to be your width. All right, this is the number that goes on the side, your first number. So as you can see right here, here is 20. So I'm going to split up 25 using expanded form. And I told my students we should know this by now, expanded form. So here's 20 and here's 5. So this would be 25 if we were to add them together. But I have 20 on top, 5 on the bottom. Now this number right here, the second number, is my length. All right. So my second number is my length. So it's going to go up here. It's going to go on top. All right. So I have 30 over here. And then I have 6 right here. All right. So that's what my area model looks like. All right. So when I'm doing double digits times double digits. So unlike the last problem where it was kind of nice because we had a 0 in one of the numbers, this one's not so nice because now we have something in the ones place in both numbers. So this is where some students kind of tend to freak out. Do not freak out. It is still easy. All right. The area model, as we discussed last week, is the exact same thing. You're going to multiply each area or each box based off of what goes together. And what do I mean by that? Well, a lot of the students in my class, we have what's called a multiplication chart. This method is very similar to using a multiplication chart. You just point to the numbers and you see which box do they match. So 20 and 30 match this box. So now I can do 20 times 30, and I should know that 2 times 3 equals 6. And then I just add my 2 zeros. So this box would be 600. All right. Next, I have 20 times 6. So now if I was to do this as a multiplication chart, I would just drag my finger, match it to the 6, and then figure out, okay, I need to fill in this box for 20 times 6. So 20 times 6, so that's what's going here, 20 times 6. All right. And we should know that 2 times 6 is 12. We just add a 0 from that 20, so that gives us 120. Now that's the top row. Now what a lot of students tend to forget is this bottom row. Do not forget this bottom row because this is important. So what we have now is we have 5 times 30, all right? So if I'm using this like a multiplication chart, I drag my fingers together and I point and I go, oh, I have to fill in that missing box right there. So 5 times 30, as you can see, 5 times 30. So 5 times 3 is 15. Add the 0, that's 150. And then last but not least, this part should be easy. What's left over? 5 times 6. See, look, 5, 6, gotta fill in that box. 5 times 6 is 30. So now the numbers are slightly easier to work with because now all I have to do is I just add all my product answers together. So I do 600 plus 120 plus 150 plus 30. So obviously 4 zeros equals 0. 5 plus 2 is 7 plus 3 more, 7, 8, 9, 10. That is 10. Carry my 1. 6, 7, 8, 9. So my final answer would be 900. Now I know some of you are going, well, what about partial products? What if the homework asks us to do this in partial products? Well, I'm going to leave my area model up here because partial products and area model are very similar to each other. The only difference is remember, we don't have a box around partial products. So let's do this using partial products. Partial products. So partial products is super easy, all right? And you're going to notice that I'm just copying and pasting what I did in my area model and just putting it here. So I'm going to rewrite my problem 25 times 36, okay? Now, obviously, unlike other problems where I'm doing single digit times a double digit or a triple digit where I split up the biggest number and then multiply the smallest number to each of the parts, with partial products using double digits times double digits like this, what we do is we do something very similar. We do something very similar. The only difference is we just put everything in expanded form and we multiply very similarly to how we did it in the area model. So for example, I have 25, all right? And I know I have to do 20 times 30 because see, look, I have 2 times 3, but that's 20 times 30. So I have 20 times 30 here. And then I also have 20 times 6. All right. So I'm just breaking the problem apart into smaller, more manageable equations. Okay. And again, the standard way where you branch is not bad. It is not banned. It's just this is what we have to teach in class. But if this is easier for you to solve, especially on the math test that we will have in the next week or so, then this is fine. This is not banned. I'm not going to say, absolutely not. You are forbidden from using it. Absolutely not. If this is easy for you to use, then you can use it on the test, okay? But for homework and classwork, we do want to experiment and get comfortable with seeing these types of methods. So obviously, as you can see, I did 6 times 20 and 30 times 20. Now we are going to take apart the 5 and we're going to branch out. And as you notice, I kind of flipped it. Instead of doing the bottom number and branching out, I'm taking my top number and branching out. Essentially, you're going to end up doing the same thing no matter how you flip them and switch them. All right, I could have started 6 times 5 and 6 times 20 and then done 30 times 5 and 30 times 20. It doesn't matter. as I said before, it doesn't matter how you flip or switch a multiplication problem, just like addition, they're going to end up with the same answer. All right. So let me go back to what I was stating before. So now we're just left with 5 times 30 and 5 times 6. So I hope you guys can see the similarities in partial products in the area model that I used for double digits. They're the same thing. One is just in a box, one is not in a box, and we just broke apart one number and distributed each of the parts to the other number. And that's one thing that we're also learning about is the distributive property. This right here is, even though it looks kind of disgusting, this would be considered the distributive property because we distributed the 20 to 36 and we distributed the 5 to 36. And you can even argue saying, well, no, you distributed the 36 to 20 and the 36 to 5. So like I said, multiplication and addition are really nice because you can flip them and switch them and still get the same answer. But now we get to the best part, which is 20 times 30. So 20 times 30 is obviously 600. 20 times 6 is 120. 5 times 30 is 150. And 5 times 6 is 30. All right. Now, I always tell my students that if your numbers do not line up really nicely, always rewrite it. But since it actually works here right now, I'm going to leave it as is. And I'm just going to add it right here. So obviously 4 zeros is 0. 5, 6, 7, 8, 9, 10. Carry the 1, 6, 7, 8, 9. And that would be 900. So partial products got us 900. Area model got us 900. So as you can see, both strategies are great. And then the last strategy I'm going to quickly go over is the standard method, which I know parents you're familiar with and students, we've talked about it. And I know some of your parents have told you about it as well as teachers in the past. And as I said before, in class, you're allowed to use it. It's just not something that we are familiarizing with ourselves right now. We are just worried about, can we use different strategies? And we want to be able to be open-minded and using different strategies where, hey, you know what? Sometimes the standard method is just too tedious. Maybe open up your mind and use the area model or partial products instead. But we're going to just quickly walk through the standard method because the standard method is not wrong either. And I just kind of want to show you and compare that the standard method will still get you the right answer, just like the other ones. Forgive me, my eraser is awful. I have to buy me a new eraser. So if we remember just quickly that the standard method, you just branch out to each part of the equation. And we're going to keep the equation the same. 25 times 36. Let me back up just a little bit. So we're going to keep the equation the same, and this is just the standard method. All right, so the standard method, a lot of you are familiar with. So now we're just branching out, and in the standard method, we always start in the ones place. So we have 6 times 5, which is 30. We carry our 3. We don't bring it down here, unlike partial products or the area model. We carry our 3. Then we do 6 times 2, which is 12, plus 3 more. So that's 12, 13, 14, 15. That's 150 right there. Now, here's where the kicker gets in. Sorry, I forgot to signify that I branched out. Now, here's where the kicker gets in. Now we have to do the 3 because we have to multiply each part by what's in the tens place, which in this case is the 3. However, whatever we do here, we have to signify that, hey, we're moving over one place value. Now, I do an X, but some of you might be familiar with your placeholder as just a 0. It doesn't matter. They're both the same. I just put an X here just to help me not get confused. That's always helped me. But if you're more of a 0 person, a 0 is just fine as well. All right, but for me, I usually do an x. All right, this x equals 0, x equals 0. So now I do 3 times 5. 3 times 5 is 15. I carry my 1. Now just be careful, because this is where a lot of students get in, is they think that when they add the 1 right here, now it's going to be a 13, or you do 3 plus 1. This is completely different, because now we're doing a completely new number. So that's why I go standard method is still allowed. It's just be careful. Be very, very careful. So anyways, to continue on, so we have 3 times 2 is 6, plus 1 is 7. All right, and my numbers not line up nicely. So now we just straight up add. So 0 plus 0 is 0. So, and I know that says an x, but as I said before, this x equals 0. 5 plus 5 is 10. I carry my 1. 7 plus 1 is 8, plus 1 more is 9. And just like in the other problems with the area model and partial products, this equals 900. All right. So I know this was a lot to take in, so I will make sure to put somewhere in the comments that only watch the parts of the video that apply to you, whether it's the array, the area model, or the standard method. But I just kind of wanted to show you the different strategies to solve double digits, and I'm hoping this helps you guys in any future homework assignments that you have, as well as the next test that we're going to be having here coming up in a couple weeks. Okay, other than that, if you have any questions, please feel free to rewatch this video, or if you are on my dojo, please feel free to dojo me. Okay, other than that, students, I hope this was helpful, and parents, good luck with homework, and if you have any questions, feel free to contact me. All right, goodbye.